Okay, question 6.5 is what is the wavelength of a photon that has an energy of 6.33 times 10 to the minus 18 joules? So we're looking for a wavelength in nanometers. Okay, once again, this is just like the other questions. Okay, so E is equal to Planck's constant times the speed of light divided by the wavelength. We know that the energy of a photon is 6.33 times 10 to the minus 18th joules. Okay. We know Planck's constant is 6.626 times 10 to the minus 34th joule seconds. Okay. We know the speed of light, which is going to be basically 3.0 times 10 to the 8th meters per second. Okay, or 2.998 times 10 to the 8th meters per second. And we then are dividing that by the wavelength. Right? And so if we solve for the wavelength, we basically get that the wavelength is going to be equal to 3.1 times 10 to the minus 8th meters. Okay, we need it in nanometers because that's what our answer is calling for. So we know that there are 10 to the minus 9th meters in 1 meter, or in 1 nanometer. So our meters cancel, we're left with nanometers, and so what we get is we get 31.4 nanometers.